Okay, so for this first problem, it says to suppose the region enclosed by y equals x squared. These are both rotated about the line x equals -1, and we need to find the volume of the resulting solid. So let's draw the graph. So I've drawn the line x equals -1 in the coordinate plane. Then I will draw the parts of y equals x and y equals x squared that are enclosed between one each other. Enclosed between one another, I should say. So these are particularly simple functions, so we see that they intersect at 0, 0, and 1, 1. And this whole shape is going to get rotated about that line, x equals -1. So when we draw the figure, it's gonna look something like this. Where these dotted lines represent an interior line. And so we have a 3D shape that is between the dotted line and the rounded portion. And we'll also have a hole in the bottom. So if we make discs that lay sideways, it's kind of like this, they'll have a hole in the middle. So it's not exactly a disc. Sometimes people call it a washer because it has a hole in it, just like a just like the physical object, a washer that people put around screws. Try my best to draw this. It's a bit hard, but okay. So if I draw if I lay these discs on top of one another, my volume will be the integral from 0 to 1, assuming I'm integrating with respect to y, because it's easiest to lay these sideways. I'll have pi times the outer radius squared minus the inner radius squared. And I'm going to draw the disk off to the side just so it's easy for us to see what the inside and outside radius are. Now we need to represent these in terms of x because our horizontal distance will be the radius. So x equals root y for that one, and x equals y on the bottom. So that root y will be our outer radius, but we've got to add it to 1 because that number tells us how far it is from the x-axis, but we need to go 1 more unit. Similarly, the inner radius will be y plus 1. When we insert these into the integral, this is what we get. So computing that is essentially what we need to do. First, we multiply everything out. And we're here. And the rest is a bit mechanical. So I'll just do the subtractions and see what we have left. So then integrating, we've got volume equals pi times negative 1/3 y to the third minus 1/2 y squared plus 2 times y to the 3/2 times 2/3. And lastly, we just plug in 1 and 0 to this. Sorry, should not scroll up if I don't have to. So this is what we get when we plug the 1 in. If we plug 0 in, it just becomes 0, so it all cancels. So doing the arithmetic, we end up with pi over 2.